Thanks, Mark. Can everyone hear me well? Well, so just after lunch, I hope everyone's excited for a session on congestion curtailment. Just testing. All right, just before we begin, these are just basic disclaimers. The views expressed here are totally mine, and the data that we've used is representative, especially because nodal analysis requires CI clearance, and we're not sure everyone has CI clearance for us to share. So it's representative figures and representative data, but overall the trend that we have in our studies. So moving on, what we are going to cover today is an overview of DNV. So I'm a senior analyst at DNV. We are a risk assurance and management consulting firm. Then we are going to move to the congestion and curtailment study that we perform as part of the Power Systems Advisory Group that I'm part of. We're going to transition from that to some of the recent market trends that we see in the North American energy industry. And we'll wrap up with a closure of our service offerings, how DNV can support you in this energy transition. We use PLEXOS. We are also customers of PLEXOS Cloud. And with that energy analytics combination, we are positioned to provide you a whole comprehensive set of services. And towards the end, I'll open up the floor for any Q&A that you have. So I'll start with the overview of DNV. We have been in the business for 157 years. We started in maritime. We started the risk assurance certification services. We also transitioned to independent assurance and risk management. We have close to 12,000 employees, and we operate in more than 100 countries. Our annual revenues for 2023 were around $3 billion. And we pride ourselves on our uncompromising standards of integrity and quality. For maritime customers, we offer services and advisory services that enable customers to safely tackle the decarbonization and digitalization aspect. But specific to energy system, we offer a whole suite of technical and economic studies that help you from the planning stage to the energization of your assets and overall trend analysis in the market. So as we know, that we have faced a lot of extreme weather events in the past few years, and climate change has been one of the biggest risks that we are trying to mitigate and trying to come up with solutions. And at DNV, we pride ourselves with our purpose, which is to safeguard life, property, and environment. And climate change being one of the biggest risks, is one of the enablers for us to be in this space. In overall, our the horizon that we've been in this business, we have supported gigawatts of renewable energy into the market. I think we've supported close to 300 gigawatts so far. Just last year, it's tens of gigawatts that we've supported through our various offerings, enabling them onto the grid. So before I get to the study, I wanted to start with a poll just to see what are the different sets of folks in the audience. So can I have a quick show of hands? Who here are utility and ISO professionals? All right. Consultants and developers, IPP traders. Any other investors? All right, so I guess we have a lot of utility ISO folks in the room, so welcome, and thank you for everyone for being here. Okay, so let's jump into the topic that we're here to discuss today. So at DNV, we do a lot of congestion and curtailment studies. This is specifically a nodal model. We subscribe to the PLEXOS platform and also to the PLEXOS cloud platform. And we use that to, sanitize, recalibrate those models, and create our own projections and assumptions for different ISO RTO regions in North America. So the economic model elements that we have, they represent the generation, transmission, and the consumption side. We do have a very low resolution of the distribution level as well, but we primarily focus on the insights on the transmission and the generation level in our model. In terms of curtailment that we model, it's primarily the economic curtailment that could be driven by congestion, or that could be driven by scenarios related to overgeneration where you have excess supply and less demand in the system. So one of the studies that we did, and this is an anonymized project with representative data, so just sort of sharing that again. It was a solar project in AEP region in PJM. It's a 100 megawatt project which had online date mid 2020s. We modeled various scenarios for this particular study. I've shared a few of them here. There was the first year base case that we had that was close to the in-service date, and there were some midterm scenarios and another sensitivity based on high renewable penetration. So an outlook if there's changes to the renewable interconnection request, or there's higher renewable penetration, what would the impact of that be on the system? So why do clients need to do these studies? What are the causes and then the effects of this? So this is a typical PPA, and this is traditional PPAs had utilities as their off-taker, but more recently with renewables and corporate renewable PPA structures, we've seen virtual PPAs in the market. For this particular project, they planned on a financially settled PPA with environmental attributes. They had a term of 20 years, and the curtailment risk that they had with the project was basically because they weren't getting compensated for any of the economic curtailment that could happen. And that was one of the drivers for the developers to understand that, hey, how much curtailment do I expect for this resource throughout its lifespan? Another risk that they had is, as part of this PPA, they had certain availability and performance guarantee. And as part of those availability and performance guarantee, they had corresponding penalties associated with it. So they had to stick to certain levels of performance that they originally entered into the PPA, and that's why it's important for the seller to maintain some level of performance and standards throughout the lifespan and have that economic viability throughout the lifespan of the asset. So we modeled this unit in our Eastern Interconnect dataset. It had a nodal resolution. We had baked in our assumptions, what our outlook is going to be for the near term, the midterm, and the long-term scenarios, and how those assumptions are going to change for these different scenarios as well. When you're doing a high renewable generation scenario, what is the level of change of those renewable parameters that you're inputting in the model? The key takeaway that we had for this asset is its basis risk, which is basically the LMP at the node, so the LMP at the project node, minus the LMP at the settlement hub. The settlement hub for this particular project was AEP Dayton. We had a very low premium for this particular project for all the scenarios that we modeled. So you could see a couple of them displayed here on the screen as well. We also saw very minimal curtailment. So this particular curtailment is only SCED curtailment. So this could, in some of these sensitivities, only on the midterm and the long-term side, we saw additional curtailment. Or in the base case, that there was actually no curtailment for this asset, which is actually good when they don't have any compensation for it. This another thing that the client wanted to understand was basically how the congestion has shifted, because that's where their exposure also lies, and they want to understand how the model's moving from the mid to the long term. And we had a similar, positive basis for congestion as well for all the scenarios that we modeled for this particular asset. Now, one of the major things that helped us to narrate the overall story for this project or this particular assessment was our modeling in PLEXOS and PLEXOS Cloud. So what we were able to achieve is help the client understand if they have curtailment, what are the exact causes of curtailment, what are those specific lines, and what are those shift factors and shadow prices that are exaggerating it, exacerbating it, or reducing it. And we were also able to help them understand how some of the key parameters, if they change, are going to impact the overall viability of the asset over the long-term period. And that was possible because we had the congestion analysis, and we were able to check the induced flow and the congestion charge, the decomposition for this particular asset. So in simpler terms, we were able to assign the cause and effect. If the asset is getting curtailed, what are the causes, and what are those specific individual elements that are causing that curtailment? And if there's higher congestion, what are those individual elements that are causing that higher congestion, and how certain changes in our assumptions or certain changes in the near to the long term can impact and perhaps reduce that risk. Then, one of the other insights that we were able to provide to them was also how certain changes in the range of those assumptions would impact the overall range of the internal rate of return for that asset as well, and how this would help them. And all these things would, in all, help them to restructure that PPA or feel comfortable with the current terms of the PPA if they are trying to get into the agreement. What I have on the screen is basically a very grayed out representation, because this is anyways representative data, but still these are geocoded lines. So we, from one of the presentations that we have from an Edge Exemplar as well, but still nodal. So these have been grayed out for a specific example. But what we see on the slide, the red bar that you see towards the right-hand corner, it tells you all the binding elements within your simulation for that particular hour. And that helps you analyze for that particular hour what are the different causes or reasons behind higher congestion, curtailment, etc. And we are able to provide these things to the client as well. I guess that's a good opportunity to have another poll. Is everyone following with me? Okay. Can Mike? The scenarios. So there are some scenarios I cannot share, but the ones that I can share, basically, we try to see if the assumptions change from our base outlook versus an outlook where you see higher renewable growth. There could be other scenarios where you could see higher load growth. How would that impact the project? Those are some general scenarios. Changes in fuel prices. These are some general things that we would try to model to provide them a range of values and the basis risk in different conditions for the asset. Yeah, sure. So traditional PPAs originally, when they were usually with the utility because there was not a lot of rec or financial settlement that was happening. Virtual PPAs, for example, I'm a developer, solar developer, and I am selling power, let's assume, to Microsoft Corporation, which is actually not using the power exactly, like not the physical delivery of energy, but they still want to use the environmental attributes and other attributes of that energy. And that's when you don't have a utility off-taker, you get into virtual PPAs.
So follow up on that question. So it'd be essentially like an unbundled PPA, like the renewable energy credit would go to a company like Microsoft, but the utility itself would still benefit from the energy being produced.
So the point of delivery would still be within the utility territory, but sometimes the PPA does not have the energy delivery option. But the PPAs can also be bundled. They can have both energy and rec included as well.
Okay.
So for your scenarios, you said there was one high renewable scenario. I was wondering, did you know where to place those renewables, or did you look at more scenarios of different placements?
Yeah, so I think that's a good question. So in nodal simulations, I think that's one of the things you have to also consider. It's not just the quantity of additional generation, it's also the location of additional generation. And we have some practices internally that help us to model that, and they are proprietary.
Okay, thank you.
It's still an estimation. Okay, any more questions? So poll 2, what are some of the major reasons for renewable curtailment? Any answers? Is it transmission congestion, system-wide oversupply, transmission outages, or just a combination of multiple grid factors or events? Yeah. So primarily congestion does, but then it's also a combination of other factors that are happening on the grid that could cause curtailment. Moving on to market trends. I want to start with some key takeaways that I'm going to cover in the next few slides. Some of these items, so congestion and curtailment, they significantly affect the revenue and long-term strategic planning for any developer, asset owners, people who are exposed to the risk with these assets. The study that I shared was basically for a generation asset developer, so it had their perspectives on that. But similar issues are faced with, let's say you're a transmission developer, they may have similar risk, they would want a similar set of analysis done as well. I'm going to expand on a few of these on the next slide, but DNV has the capability to value our asset over its lifetime, not just based on the fundamental analysis that we do with PLEXOS, but also based on some of the market curves that we see over the long term. And we are able to provide a hybrid projection for the next 10 to 20 years that could help you actually value that asset to its true value, capturing the risk both in the near term using the market curve and the risk and the trend over the long term using the fundamental curves. One of the key trends that we've seen, and that's especially coming from the MISO 2023 State of the Market report. One of the notes that the independent market monitor made is the grid enhanced technology, so the use of ambient adjustment ratings or dynamic line ratings, and how they could help reduce overall congestion in the system. One of the examples that they quoted was from winter of 2023. MISO usually switches to winter ratings on November 15, but they had $34 million in congestion value or congestion cost for a 1 week prior to November 15, where they were actually on summer ratings in the first 2 weeks of November. And if they had switched to winter ratings earlier, or if they had ambient adjusted or DLR ratings, they would have been able to mitigate the congestion, which they actually witnessed once MISO switched to winter ratings after November 15. The other example that I have is very recently from Pacific Gas and Electric. So PG&E wanted to reconductor lines, and they had the total estimate cost for reconductoring around $80 to $90 million. And the lead time was actually something that they weren't able to plan or develop it at such a long horizon. They wanted solutions quickly. So that was one of the reasons why they had to find some creative ways of finding an alternative solution. And one of the alternative solution that they did find was they placed storage towards the end of that distribution line. In that way, it added, it acted also as a release valve to the overall constraints that they had with that line, but it also acted as a reserve of energy for them. And the original solution of reconductoring, that was close to $90 million, and they were able to mitigate that in the near term at least to around $10 million. Some of the key trends that I'm also going to cover is the interconnection queue challenges that we have and how they impact the overall congestion curtailment outlook, the grid. We have faced some of the transmission development delays and how that has impacted the flows and the price differences that we see between the regions. One of the things that we also see, not just more recently in the offshore wind space, where you have some supply chain constraints that may result in delayed deployment times, but also in other resources where compared to other footprints or other regions, for example, China, US still has higher lead times to put resources on the grid compared to those regions. And what are some strategies that we could use to reduce those timelines? So one of the key market trends that we see is there's approximately 3 terawatt of proposed generation capacity that's skewed across 7 ISO RTOs and 44 non-ISO balancing regions. And if you see on the graph, it's somewhat spread out more evenly across the US. So it's not one specific region that is facing this problem. It is more of a US-wide problem that we see today. And one of the impact of having this is there is a lot of risk involved for developers when they're trying to place these assets, and when they're trying to understand the risk and exposure to their returns and their revenues, because the assumptions may widely differ based on how these queues are realized over the midterm. And this is where the studies that we do, congestion, curtailment, and overall market analysis, is helpful for them to assess what could their potential floor be and what is the ceiling that they could maybe aim for. I talked about some of the transmission development delays. This particular figure is from a US DOE Grid Deployment Office. And one of the key insights that they're trying to deliver in this is in almost most of the regions across US, you see the need for transmission development to alleviate congestion. you see the need for transmission development for reliability purposes. And that's pan-US. One of the other things that we have noticed in the past is between 2010 to 2022, US effectively energized around 33,000 circuit miles of new or rebuilt transmission that was over 100 kV. But 20% of those projects, they were at least delayed by 3 or more years than their actual planned date, primarily by 3 reasons. Permitting, so local regulations, or they had lack of community engagement where they had a lot of community barriers for those projects to move forward. And we do see these examples more recently as well with some of those high voltage lines that are in the Northeast that have gone through various rounds of review and approval, and then they have been stuck. So these changes also impact the assumptions that go into these congestion curtailment study and what would be the overall risk to that project and the PPAs that have been entered into, and if they have to restructure them accordingly. Interregional price differences. So US is within 3 interconnects. It's Eastern Interconnect, ERCOT, and WEC. There are some connections between the 3, but they are still separate systems. This is a study done by LBNL, and NREL has also been a part of it, which tries to illustrate the point that interconnected systems may deliver the value, especially in certain winter events, certain extreme weather events, where it would be beneficial for the consumer as a whole to have net value and net lower cost of energy and lower production costs. And these regional differences sort of illustrate that point. So we have seen a lot of policy changes. We have seen new policy coming from FERC Order 2023. Inflation Reduction Act is signed into law in fall 2022. One of the key impetus of that has been that almost an equal amount of generation that was in the queue has been added since the passage of that law. And how that impacts is the studies. For example, the studies that were performed before fall 2022, when this law was still not signed, which only considered things that were binding at that time, they had to drastically update themselves as the queue updated within the last 1.5 years. And those assumptions also had an impact on the overall price curves that were based on those assumptions as well. So IRA has brought more than 1 terawatt of solar, wind, and storage interconnection requests since fall 2022. One of the key changes that we have seen with this policy is transferability. So transferability of tax credit that has opened up the revenue streams, not just related to solar, but all other resources as well. And it's not tied to one entity where they can transfer those tax credit to other entities as well. That has also led to the economic viability of these generators. FERC Order 2023 helps us to put these resources onto the grid. It's at least a step in the right direction where you can have this outsized impact and especially accelerate the energy transition. So I'm going to wrap up with the service offerings that we have to support with a wide range of services. We have an energy economics group. We have a resource integration group that does resource integration studies. We do special studies, EMT studies. subsynchronous studies, and we support both transmission and distribution studies for the whole of North America. I'm going to wrap up, and thank you for your time. I have my QR code. If you have any questions, we can set up a time and we can discuss.